Hello everyone. In the previous lecture we have discussed about the Newton's laws of motion and basic terms used in the derivation of conservation laws. Today in this lecture we shall derive the law of conservation of linear momentum. Let us state the law. If the net external force acting on a system is 0, then the total linear momentum is constant. Or we shall define it in another way. The total momentum of a system remains constant in the absence of external force. This law is universal because it is not only true for the collision of astronomical bodies but also it is true for the collision of subatomic particles. We are going to prove this law by considering two systems, a system of single particle and a system of two particles. Let us consider the first case, a system of single particle. Let us assume that you are moving on a bike with some speed. If you want to increase the speed of your journey, you have to use the accelerator or you have to put the accelerator. That means you are applying some external force to increase your speed. If you won't apply the external force, the accelerator, then there will be no change in the speed of your journey. That means the momentum of the motion of your vehicle will be constant. The same way, let us consider a particle of mass m moving with the velocity v. Then from second law of motion, the rate of change of momentum is equal to the force applied on the system. If there is no external force acts on a body, then the rate of change of momentum of that body is 0, which implies that the momentum of the body is constant, which is the law of conservation of linear momentum. Now we shall consider the second case of a system of two particles. Here we are going to consider the elastic collision, that too head-on collision. Head-on collision means what? If two vehicles are coming in the opposite direction and collide with each other, that is an example for head-on collision. Let us consider two bodies A and B of masses m1 and m2 moving in a straight line in the opposite direction such that they approach each other and collide with one another. Here, before collision, both the bodies A and B are moving with the velocities u1 and u2 in such a direction that they are approaching each other. For a short interval of time, they collide each other. That is, during collision, the time of interaction is delta t. After the collision, the bodies A and B are moving with the velocities v1 and v2 in the opposite direction and they get parted. Now, from Newton's second law of motion, the force exerted by body A on the body B is equal to the rate of change of momentum of the body B. That is FAB, that is the force exerted by body A on body B is equal to the change in momentum of body B divided by time of interaction, that is delta P Pb divided by delta T equal to m2 v2 minus m1 v2 divided by delta T. Sorry, m2 v2 minus m2 u2 divided by delta T. This is the force exerted by body A on body B. Similarly, the force exerted by body A on body B is equal to the rate of change of momentum of A, that is force BA equal to change in momentum of body A divided by time of interaction delta T equal to m1 v1 minus m1 u1 divided by delta T. Now, according to Newton's third law of motion, force FAB equal to minus of force BA. That is m2 v2 minus m2 u2 divided by delta T equal to minus of m1 v1 minus m1 u1 divided by delta T. Then m2 v2 minus m2 u2 equal to m1 u1 minus m1 v1, that is m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2, which is the total momentum of the system before collision is equal to the total momentum of the system after the collision, which proves the law of conservation of linear momentum. This is the proof of the law of conservation of linear momentum in case of a single particle system and in case of two particle system. In the next lecture, we shall consider the Newton's law of impact. Thank you.